Welcome to this comprehensive guide on Tableau interview questions. In this video series, you'll master the fundamentals of Tableau that are essential for business intelligence interviews. Tableau is one of the most powerful data visualization and analytics platforms used across industries. Today, we'll cover the core concepts including calculated fields, parameters, dashboard design principles, and business intelligence workflows. These topics are frequently tested in interviews and form the foundation of effective data analysis using Tableau. Whether you're preparing for your first data analyst role or advancing to a business intelligence position, understanding these fundamentals will give you the confidence to succeed in your interviews. Calculated fields are the backbone of advanced analysis in Tableau. They allow you to create new data fields by applying formulas and expressions to your existing data without modifying the original dataset. Think of calculated fields as custom formulas that transform your raw data into meaningful insights. There are three main types of calculated fields you need to understand. First, basic calculations, which include simple mathematical operations and string manipulations. Second, level of detail expressions, abbreviated as LOD, which give you precise control over aggregation levels. Third, table calculations that perform computations across the structure of your data table. Mastering these three types will enable you to handle complex analytical requirements and answer challenging interview questions with confidence. Basic calculated fields form the foundation of data transformation in Tableau. Mathematical operations are the most common type, where you can multiply sales by 1.1 to add a 10% tax calculation, or divide profit by sales to calculate profit margins. These operations help you derive new insights from existing numerical data. Conditional logic using if statements is equally important for categorizing data. For example, you can create a field that labels sales above 1,000 as high and sales below that threshold as low. This type of logic helps in segmenting data for better analysis. When writing these calculations, remember that field names are enclosed in square brackets, and you can combine multiple conditions using logical operators like AND and OR. Level of detail expressions, or LOD expressions, provide granular control over how your calculations are aggregated. These expressions are enclosed in curly braces and follow a specific syntax pattern. Fixed LOD expressions compute values at a specific dimension level, completely ignoring what dimensions are present in your view. For example, fixed region sum of sales calculates total sales for each region regardless of other dimensions in your visualization. Include LOD expressions add extra dimensions to your calculation beyond what's already in the view. For instance, include customer sum of sales includes customer-level detail even when customer isn't shown in your visualization. These expressions are powerful tools for complex analytical scenarios and are frequently tested in advanced Tableau interviews. Table calculations operate on the structure and layout of data within your visualization. They compute values based on the table structure rather than the raw data source. Running totals are one of the most common table calculations, created using running_sum function applied to your measure. This calculates cumulative values as you move through your data table. Percent of total calculations show each value as a percentage of the overall total, using the formula sum of your measure divided by total of sum of your measure. Table calculations are particularly useful for trend analysis, comparisons, and showing relative performance. They respond dynamically to filters and changes in your view structure, making them ideal for interactive dashboards. Sets are powerful Tableau objects that return true or false values, making them perfect for conditional logic and calculations. When you reference a set in a calculated field, it acts as a Boolean expression. For example, you can use an if statement that checks if a record belongs to your top customer's set, then returns the sum of sales, otherwise returns 0. This creates a calculation that only shows values for your top customers. Sets are also excellent for dynamic filtering. Using the IIF function, which is a shorthand for if then else, you can filter measures based on set membership. For instance, IIF function with customer set returns profit for set members and null for non-members. This approach allows you to create flexible, user-driven analysis where the underlying logic adapts based on set membership. Parameters are dynamic input controls that make your visualizations interactive and user-driven. Think of parameters as variables that users can change to modify the behavior of your calculations and views. Parameters enable interactive analysis by replacing static values in formulas with user-controlled inputs. Common use cases include creating dynamic measures where users can switch between different metrics, implementing date range filtering with custom start and end dates, building what-if scenarios for business modeling, and setting reference line values that users can adjust. Parameters transform static dashboards into dynamic, interactive experiences that adapt to user needs. They're essential for creating professional business intelligence solutions and are frequently discussed in interviews focusing on dashboard interactivity. Parameters support 4 main data types that determine what kind of values users can input. Number parameters accept whole numbers or decimal values, perfect for thresholds, multipliers, or quantities. String parameters handle text values, useful for dynamic titles, categories, or search functionality. Date and datetime parameters enable time-based filtering and analysis. Boolean parameters provide simple true or false options for binary choices. Each parameter type offers 3 control options. The all control creates a text input field where users can type any valid value. The list control provides drop-down menus or radio buttons with predefined options. The range control creates slider interfaces, perfect for numeric parameters where users need to select values within specific bounds. Choosing the right combination of data type and control type enhances user experience and prevents input errors. Effective dashboard design follows key principles that enhance user understanding and decision-making. Clear visual hierarchy guides users through information in order of importance, using size, color, and positioning strategically. Consistent formatting creates a professional appearance and reduces cognitive load by maintaining uniform fonts, colors, and spacing throughout your dashboard. Minimal cognitive load means presenting information in digestible chunks without overwhelming users with too many visual elements at once. Purpose-driven layout ensures every element serves a specific analytical goal. Layout best practices include following the Z-pattern reading flow that matches natural eye movement from top left to bottom right. Group related content together using containers and spacing to create logical sections. Use whitespace effectively to separate different areas and prevent visual clutter. Design with mobile-friendly sizing in mind, ensuring your dashboards remain functional across different screen sizes and devices. Dashboard accessibility ensures your visualizations can be used by everyone, including users with disabilities. Web Content Accessibility Guidelines, or WCAG version 2.2 Level AA, provides the framework with 4 core principles. Perceivable means adding alternative text for images and maintaining sufficient color contrast ratios. Operable requires keyboard navigation support and avoiding content that causes seizures. Understandable involves clear labels, consistent navigation, and logical information structure. Robust ensures compatibility with assistive technologies like screen readers. Key accessibility requirements include using colorblind-friendly palettes that don't rely solely on color to convey information. Provide meaningful titles and captions that describe chart content for screen reader users. Design accessible filter controls with proper labels and keyboard support. Establish logical focus, order so users can navigate systematically through interactive elements using keyboard or assistive devices. Business intelligence workflows in Tableau follow a systematic development process that ensures reliable, scalable analytics solutions. The BI development process starts with connecting to and preparing your data sources, including cleaning, transforming, and structuring data for analysis. Next, you build calculated fields to create the metrics and dimensions needed for your specific business requirements. Then you create interactive views that allow users to explore and analyze data from multiple perspectives. Finally, you design comprehensive dashboards that bring together multiple views into cohesive analytical stories. Deployment and governance involve publishing your completed work to Tableau Server or Tableau Cloud for organizational access. Set up refresh schedules to keep data current and automated. Manage user permissions to control who can view, edit, or share different content. Monitor usage and performance to ensure your solutions continue meeting user needs and maintain optimal performance as data volumes grow. Success in Tableau interviews requires both technical mastery and effective communication strategies. From a technical standpoint, master calculated field syntax including basic operations, string functions, and date calculations. Understand level of detail expressions thoroughly, including when to use fixed, include, and exclude expressions. Practice parameter implementation across different use cases like dynamic measures, filtering, and what-if scenarios. Know performance optimization techniques such as extract usage, efficient filtering, and query optimization. Your interview strategy should focus on explaining your thought process clearly rather than just providing answers. Interviewers want to understand how you approach problems and make decisions. Show real-world examples from your experience, demonstrating practical application of Tableau concepts. Discuss best practices for data visualization, dashboard design, and user experience. Always ask clarifying questions to ensure you understand requirements before proposing solutions. Remember to practice hands-on scenarios and prepare for technical demonstrations where you might need to build calculations or visualizations during the interview process.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.